Okay, 4.1, radian measure and degree. So we're going to be using both radian measure and degree when we go through things, and you don't even know what radian is, but you will. Okay, starting position of a ray is called the initial side. Okay, if you think about it, any angle, we've drawn angles like this, yes? And you know what an angle is? But what an angle actually is a starting or initial side, and you take this and you move it up. And so what you're seeing is the first picture of it and the last. You're only seeing one ray, but you're seeing it in how many positions? 2. Does that make sense? So initial is where it starts. The vertex is back here. You should know that already. And terminate. That's why plane terminals are called terminals, because they terminate there. They stop. So it starts at the initial and stops at the terminal. I will very rarely say side. I usually say ray. Is there any difference between the two things? No. This arrow shows the direction of movement. That's why you have to put an arrow on it from now on, because we can have negative directions and positive directions. I hope you're just drawing a picture.
Yeah.
Are we done?
Yeah.
Okay. The end point of a ray is the vertex. I already said that, right? Okay, standard position. We like our angles in standard position. We will put them there all the time. Standard position is where the vertex is at the origin. See that? And the initial ray, I hate side. I hate the word side. Initial ray is on what axis? What axis is that? X, and it's the positive x-axis. When angles go up, see how this is going counterclockwise? It goes up. That's positive. Guess what happens when it goes down? It's negative. So let's say this one would be 120 degrees. This one would be negative 120 degrees. Good? Lighten, you good?
Yeah.
Okay, this just talks about the positive and negative, which I already talked about, right? Now, we have variables for angles. We have alpha. Oh, I can't underline it. We have alpha. We have beta. We have theta. There is a whole Greek alphabet. Theta is one we will use the most often. But I can use off all of them. They're just a name for an angle. Just like we have X, Y, Z, that's just a variable. Okay? Alpha, draw it like a little fish. Beta is a big with long B. And theta is a circle with a line through it. Let me know when you're down to the bottom, because I don't want you to be writing when I'm talking about these. Okay, coterminal angles. What does co mean in front of any word? Like co-president. What's that mean?
There's two.
There's
or
two.
more.
They share an office, right?
Yeah.
Okay. So if this is a co-terminal angle, they share what? They share what?
An initial angle.
Not initial. They share a terminal side. Okay? So co-terminal have the same terminal side. So, bless you. In this picture, alpha is a positive angle that stops in the third quadrant. Because remember, it's 1, 2, 3. Okay? Beta is a negative angle and stops in the third quadrant. But do they share this terminal side? Yes? So the alpha and beta would be co-terminal angles.
So is the line in the third quadrant the terminal?
Yep.
One?
Because this is the initial
Mhm.
and this is the terminal.
Okay.
Okay? So the alpha is how big? About? How far is this? From here to here. How far is that? 90. How far is that? How far is that?
270.
Okay, so alpha ends here. So what do you about think it is? What? 245? Maybe.
225.
Huh?
225.
225? Somewhere right there. I'd agree with those. Okay, what about beta? We're going negative now, so this is negative 90, yes? And this is negative 180, so it's about, okay? What do you think, with a picture like this, what do those two angles add up to be?
360.
Why?
Because
Why?
it's a circle.
It's a circle. So those two together would be 360 degrees. So if I told you alpha, could you figure out beta? If I told you beta, could you figure out alpha? Yeah. Okay. So look at the next picture. Alpha and beta are again coterminal angles. But what's the difference there? How big do you think alpha is this time?
45 degrees.
45 degrees. Beta is a positive angle, isn't it? How do I know it's positive?
Because it's
Look at the arrow,
it's going.
right?
Yeah.
Okay. But how can they be coterminal if I just said it was 360? It ends in the same spot. And how far is it from here back to here? 360. So my magic number to find coterminal angles is what? 360. So if alpha is 45 degrees, how would we find beta? Well, because I started here, I started at the initial and went past 45 and then came back to it. 360 plus 45. So 405 degrees? About, right? We're guessing. But how far is between those two? 360, right? Could I do this again? Are those still coterminal? Yes, because they still share the terminal side. How many times did I go around from there? I went once, twice, and then 3 times. So it would be 45 plus 3 times 360. Is there any stopping how many coterminal angles an angle can have?
No.
Nope. Make sense? Can I have positive coterminal angles and negative coterminal angles? Yes. Because if we say this is negative 135, then this is positive 225. But are they coterminal angles to each other? Yes. Does that concept make sense to you? Okay, there's an important reason why, because later on when we do sine, cosine, and tangent, as long as they have the same terminal side, no matter what the angle is, how many times you multiplied 360 and added it to it or subtracted to it, it has the same sine, cosine, and tangent, which will make our life easier. Am I good, Savannah? Yeah. Okay. Okay, radian measure. 1 radian. 1 radian is the length of the radius. Okay, so if I took a piece of string and measured this radius right here, and then took that radius and laid it on the outside of the circle, that's 1 radian. Does that make sense? Why does it have to be a piece of string and not a ruler? I have to be able to curve it. And I'm going to tell you that happens every circle. There is approximately 6 point...
Excuse me, is Savannah Mason there?
Yes?
I have her glasses in the office.
Oh.
She's available to come.
Okay, thank you.
Thank you.
There's approximately 6.28 radian, that's 1 radian, in every single circle. What's 6.28 remind you of? Where do you think that number comes from? Pi. It's 2 pi. So how many radian are in a circle? 2 pi. And I'm serious, guys. That means, see this little circle? Right here? I'm holding up. This little circle has 6.28. That circle has 6.28. The clock. What's another really big circle?
My tire.
Your tire. What about a water tower that's circular?
The earth.
The earth. Every single circle of an activity I used to make you guys do, and I should make you do it. Go around the school and you have to find me 6 different circles and measure their radius and then figure out how many radian make up their circumference.
Just make if we do that, I'm taking my time.
That's probably why I don't do it anymore. So, I can draw this arc.
What's it say in between the lines on the outside of that? On the outside of the angle.
Oh, S equals R. So we don't call it R because R stands for what? Radius. So we don't call it R, we call it S. Thank you for asking that. This arc length is called S. Okay. So definition of a radian, this is a book definition, is theta equals S over R. Like that is the definition of a radian. And what that means, here was the picture, right? That, just the portion of the circle. Well, this was R. This is S. And theta is an angle, yes? Okay. So those are 3 variables. An angle, an arc length, and a radius. If you have 2 of those, can you find the third? Because the units of measure for S and R are the same, the ratio is S over R has no units. Because it'd be inches over inches or centimeters over centimeters or whatever. And it's a real number. And it just says at the bottom, note that it is 1 when S equals R. So this angle right here isn't in degrees, it's in radian. Okay? So if I asked you for the angle and you use this formula, you would not put a degree symbol in it. You would have a radian measure. You wouldn't have a degree measure. So we're going to have to learn some conversion. Oh no. You already know it, and you don't know you know it. Lots of definitions today. This is just a picture of what I told you before. So 2 pi is approximately 6.28. You guys figured that out, right? So this is 0 degrees, isn't it?
Yes.
Yeah. So wouldn't it be 0 radian? And we're going to put an R for today, but we're not going to do that later on, okay? So what was over here? How many degrees was over here? 180 degrees. Okay. How many degrees is right here? $90, right? What about the bottom? 270, right? And then if I come all the way around, isn't this 360 degrees? Okay. Well, if we go all the way around, it's also 2 pi radian, isn't it? Yeah. So what would 180 be in radians? What? One what? If 360 is 2 pi,
6.14 times 3. Or 6.28 times 3.
1.5 pi.
no, not one and around, right here. If I go there. If this is 2 pi, if I go all the way around, what happens if I just go right here?
1 pi.
1 pi, thank you. When you said 1, I wanted you to say pi. Well, what if I stopped at 90? What would it be?
Half a pi.
So pi over 2. So we got half pieces, right? So I got a half a pi, and then I got 2 pi over 2, which is a pi, yes? And then what do I have it?
3 pi over 2.
3 pi over 2. Look at that.
Nah, make me a pi. No.
Bladen's hungry now.
Yeah. make me some
Okay.
pi.
So I kind of am getting ahead of myself just because it fits here. But I wanted you to see that connection. You saw that it was 2 pi if I went all the way around, right?
Yeah.
And all we did was use our fraction, what we know about numbers, to get the rest of it. We will learn here and 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 here. We will learn all those angles. But if you think about it, there's infinite number of angles in a circle, correct? And I'm going to only ask you to learn 1, 2, 3, 12 plus 4, 16. That's not bad, is it? And actually, you only have to learn 3 and then put positive and negatives on it. But that's what's coming. Okay, so we just did this. I just did it without doing any of this math. Half a revolution was how much? Halfway around the circle was pi. A fourth of a revolution was how much? Pi over 2. And then I had 1 pi over 2, 2 pi over 2, and then what? 3 pi over 2. Now, what if I wanted a sixth of a revolution? It'd be 2 pi over what? 6. And it would be pi over 3. So are we going to do a fractions? A lot.
No.
Sorry. Am I good? Okay, so these are other common angles. We have pi over 6, pi over 4. You don't need to write them down because we'll find them. Pi over 6, pi over 4, pi over 2, pi, and 2 pi. I'm going to tell you this is 30 degrees, 45 degrees, and 60 degrees. How did I get pi over 3 for 60 degrees? Or let's break it down. How many pieces of 60 degree do I have in pi? I have 3, right? So I would divide pi by 3. If I cut them in 45 degree pieces, how many pieces would I have? 4. So it would be what? Pi over 4. Well, 30, how many 30 pieces can I cut? 6. So it's pi over 6. How many times does 30 go into 180, guys? 6. How many times does 45 go into 180? 4. How many times does 60 go into 180? 3. It's all fractions. Aren't you just getting more excited by the minute? Okay, quadrants. You know quadrants are 1, 2, 3, 4. Yes?
Yes.
Counterclockwise, we know this. Okay, so we talk about quadrants. We say from 0 to pi over 2 is quadrant 1. Is also from 0 degrees to what? 90 degrees. Quadrant 2 is from 90 degrees to what?
180 degrees.
And it is pi over 2 to pi. Quadrant 3 is pi to 3 pi over 2. So, and it is 180 degrees to what? 270. Fourth quadrant is from 270 to 360. In your brain, you need to start as soon as possible thinking about these things just like back and forth. If I tell you 4 over 2, do you think 2? Yes. If I say 180, should you think pi? Yes. If I say pi, should you think 180? Yes.
Apples.
Apples, because you like apple pie. I really don't know where I'm supposed to be stopping today, so I'm just kind of going. Am I good, Jaden? Okay, two angles are coterminal when they have the same initial side and terminal side. Did we already go over that? Yes. Okay, so example, 0 and 2 pi are coterminal, aren't they?
Yes.
Yeah. Because you start at 0 and you go to 2 pi. I start at 0 and I stop at 360. Or 0 and 360, 0 and 2 pi, coterminal? Yes. Okay. As are pi over 6 and 13 pi over 6. Oh my gosh, that's a lot. Now why? Well, let's think. Pi over 6, 6 goes into 180. How many times? 30. So it's a 30-degree angle. You'll start getting there and not have to translate back and forth. So it's small, right? Okay, so this is pi over 6. Well, how is 13 pi over 6? Well, what fraction is that? 6 goes into 13 how many times? Twice. So it's a whole revolution, yes? And how many more pieces? Because it's 12 pi over 6 plus pi over 6. So that's how they're coterminal. And what is that magic number? Not 360 when it's radians, it's what? Nope. 12 pi over 6 is 2 pi. Okay, so are you going to have to get common denominators?
Yes.
Yes. Okay, find an angle that is coterminal to theta. Add or subtract. An angle that is coterminal to theta. Add or subtract 2 pi, or this should be an or, not times. 2 pi or 360. And why are we using 2 pi or 360? Because it is how much? 1 revolution. A given angle theta has infinitely many. We've already talked about that because can I keep going around and around and around and around a circle? Yes. So to find every single one, all coterminal angles, all you have to do is set plus and minus 2 pi. And what's the n tell you? How many times you do what? Go around a circle. I usually don't write it 2n pi. I write 2 pi n. I like to keep 2 pi in the same place, but does it matter? No, it's 2 times pi times n. So if it asks you for 1, you add or subtract 360. And if it asks you for all, you put what? Plus or minus. Or you could also do plus or minus 360, couldn't you? When do you put 360? When you're in what? Degrees. When do you put 2 pi?
When you're in radians.
And when you're in radians. Radians. Yeah, not radius. Questions? Okay, find one positive and one negative coterminal angle. So I'm going to have to add and subtract. Okay, so 13 pi over 6. So let's draw that one first so we know where it's at. You're going to be drawing angles a lot. It helps. Well, 6 goes into 13 more than twice, yes? So again, that's 12 pi over 6 plus pi over 6. So it's going to be here, but I have to go all the way around and then some, don't I? Okay, so I'm in radians, so I'm going to be adding, subtracting 2 pi. Correct?
Yes.
Okay. Sometimes you could subtract twice and get a positive and a negative. Sometimes you could add twice and still be negative. It depends where you started, right? So don't just think just because I added once, I'm positive. Because could I have to add 4 pi? Yes, if the angle was bigger than 2 revolutions, right? Okay, so what do you guys want to do first? Add, subtract, add, subtract. What do you want to do? Add. So I have 13 pi over 6 plus 2 pi, but I have to get what? Common denominators. So when I have 6 as a denominator, my numerator is 12. So that would be 25 pi over 6. You notice, how am I making my fractions? Am I slanting my fraction bar? No, don't do it. Got it? Especially when you're working with the numbers, because those bars, when you start doing this, get sloppy, and sometimes you forget it's a bar. Got it? Up and down. Save yourself some headaches. So I have positive, and if I keep adding, I'm only going to have positive, and they want one positive and one what? Negative. So I need to subtract. If I subtract just 2 pi, am I going to get a negative number? Why not?
Because it's more than 2.
It's more than 2 already. So the magic number is 2 pi 360. Can I do anything smaller than 2 pi? No. Like, other than a whole revolution. Does that make sense? It has to be a multiple of 2 pi only.
4.
So we're going to do 4 pi. Because 2 pi wouldn't be enough, would it? Nope. So I get common denominators, so my numerator would be what? 24 pi over 6. So 24 minus 13 would be negative 11. Am I right?
Yeah.
So negative 11 pi over 6. My other thing, do not write your negatives like that. Why?
Because it looks like it's just part of the.
It looks like it's part of the fraction bar. Does it matter if it goes to the numerator or the denominator? No, but it never goes to both because a negative and a negative would be a positive. And it's weird to put it in the numerator, isn't it? Yeah. Okay, you guys try that one. Find a positive and negative coterminal angle for negative 2 pi over 3. Hate where the negative is, but do I have a choice when the computer puts them? No. So do you need to, when you write it, you should move it up to the 2. Do yourself a favor. Okay, I got 4 pi over 3 and negative 8 pi over 3.
Wait, what did you do with the negative one?
I added them. Because it's negative 2 pi and negative 6 pi. So it'd be negative 8 pi.
So,
Yes?
yeah.
Okay, now, could you guys have done something different? Could you have done negative 2 pi over 3 minus 8 pi? How many revolutions is that?
4.
It's 4, right? Divide 8 by 2, it's 4. So that would have been 3, so that would have been 24, so that would have been negative 26 pi over 3. Are they still coterminal?
Yeah.
Yes. Now, when you look in the book, they'll say answers may vary. Why? Because there's a lot. Now, I am going to tell you that they usually do the first positive and the first negative. The book would not have added here. They would have subtracted 2 pi and got pi over 6. And subtracted again and got 11 pi over 6. Are they both, is pi over 6 positive? Yes. So when you're looking in the book, you just got to say, okay, is mine the same as theirs? If you're checking your answers, okay? Because sometimes they might not be. I know when I have something bigger than 2 pi, I usually add and add or subtract and subtract just because I like it better. But sometimes I'll give you something that is 3 revolutions. And then you've got to come back 3 revolutions before you even start, right? So you got to think about where you're at. And we got a long time with that. Okay, complementary, you should know this. Shouldn't even have to write this down. Complementary angles equal what? 90. Or now what? Pi over 2. Supplementary equal what? 180 or pi. Pretty sure I'm in tomorrow's already. This may be tomorrow's. We'll do one more slide and we'll call it good for the day. We're good. We're good for the day. We're not going to that one. Okay, now your assignment looks rather large. Do you think